All right. Dolphins are at the top of the oceanic food chain, which causes dangerous substances such as mercury to concentrate in their organs and muscles. This is an important problem for both dolphins and other animals like humans who occasionally eat them. For instance, this is particularly relevant in Japan, where school meals have included dolphin at times. So here, we'll identify a confidence interval for the average mercury content in dolphin muscle using a simple random sample of 19 dolphins from the Taiji area in Japan, which would be the southern part of Japan. The data for the 19 dolphins are summarized here. The minimum and maximum observed values can be used to evaluate whether there are any obvious outliers. Measurements are in terms of micrograms per wet gram of muscle. Note that the Japanese regulation level is 0.4. And you see that my minimum is 1.7, so the minimum mercury content was 4 times the regulation level. More than 4 times, for that matter. All right. So let's compute and interpret a 95% confidence interval. And we need to start with the conditions. And recall the first condition is independence. Well, we're told at the beginning that this was a random sample, so we will assume independence. And normality, well, both z-scores, all z-scores in the data set are between -3 and +3, so there are no obvious outliers. The way you compute the z-scores is you take, the z-score for the minimum is you use the minimum value minus the mean of 4.4 divided by a standard deviation of 2.3. For the maximum, I use the maximum value of 9.2 minus 4.4 from the mean divided by 2.3. I get 2.09. So the conditions seem to have been met. All right, next up. The point estimate is the sample mean, so 4.4. Standard error would be you take the standard deviation of 2.3 and divide by the square root of the sample size. Sample size was 19. And you get 0.528. Degrees of freedom, sample size -1 is 18. As for the confidence coefficient, we would go to 95% confidence, 18 degrees of freedom, gives me 2.10. Okay. So, again, my 95% confidence coefficient is 2.10. So, point estimate plus or minus confidence coefficient times standard error, 4.4 plus 2.10 times 0.528. That gives me the upper bound. 4.4 minus 2.1 times 0.528 gives me the lower bound. And you see that goes from 3.29 to 5.51. So we are 95% confident that a Rissos dolphin has an average mercury content between 3.29 and 5.51 micrograms of mercury per wet gram of muscle. Again, the Japanese regulation level is 0.4, so the average dolphin has at least 8 times that amount.